Bottleneck analysis is a disciplined way to understand where a manufacturing system loses speed and value. In practical terms, it identifies the single step, resource, or machine that limits the overall throughput of the entire process. No matter how efficient the upstream or downstream operations may be, the bottleneck determines the pace of production. For an operations manager, the first task is to observe the full process end to end. Material flow, cycle times, queue lengths, downtime, rework, and staffing levels all reveal where work accumulates. The bottleneck is usually visible where inventory builds up, waiting time increases, or output becomes inconsistent. It is not always the slowest machine on paper. Sometimes the real constraint is a changeover delay, lack of materials, poor scheduling, or a quality inspection step that is too slow. Once the constraint is identified, the goal is to improve that part of the process before investing heavily elsewhere. Adding capacity to a non-bottleneck step does not raise total output. By contrast, even a modest improvement at the bottleneck can increase throughput across the entire line. This may involve reducing downtime, training operators, improving maintenance, simplifying work instructions, or balancing labor more effectively. The manager must then confirm the impact with data. After changes are made, production rates, lead times, and defect levels should be measured again. If the bottleneck has moved to another step, the analysis continues. In this way, bottleneck analysis becomes a continuous improvement practice rather than a one-time exercise. Used well, bottleneck analysis helps a manufacturing operation focus resources where they create the greatest return. It improves flow, reduces waste, supports delivery commitments, and strengthens overall productivity.